Okay, in this video we're going to be talking about triangle congruency shortcuts. So instead of having to prove all of your angles being congruent and all of your sides, because that takes a lot of time, we actually have 4 shortcuts that automatically say my triangles are congruent. So these are my 4 shortcuts, so I would pause the video, write them down on your triangles. Okay, again, it takes 2 triangles to say they're congruent. I'm going to show you an example of what they look like on one triangle for each of them. Okay, so the middle thing is always the thing that's included. So in this one, your angle is included, which means the other 2 things need to run into it. So I've got a side, an angle, and a side that will be congruent to another side, angle, and side in the other one. So you can see how your sides run into that angle. It's included in it. Okay, my next one, this is the one that's included. Okay, so I've got an angle, and then a side. So that angle and this side bump into the other angle. Okay, a lot of the times I say pick a direction. So I label angle, angle, side, and then I pick a direction to follow alongside my triangle to figure out what of my 4 shortcuts. If I went the other way, it would be side, angle, angle, and I just have to realize that's backwards of what one of my 4 shortcuts is. Okay, my next one, side, side, side. So I've got 3 sets of sides being congruent. That's the easiest one. And then angle, side, angle. Again, this one's going to be included. So an angle, a side, and an angle. Those 2 angles run into it. So first, I always label on it if I'm trying to figure out what they are. So an angle, a side, and an angle. I pick a direction to read it on the triangle, ASA. So those are my 4 shortcuts to tell me the 2 triangles are congruent. Okay, so we're going to determine what it are. So some of these are pretty easy because I give you the angles straight up. Some of them you might have to find other parts that are congruent, whether it is, I always check for vertical angles first. If they share a side or angle, that means they're congruent. And then I look for parallel lines. Because if I have parallel lines, I will have alternate interior angles, which are congruent, or I'll have corresponding angles, which are also congruent. So those are the things I look for to make more congruencies. Okay, so this one here, if I go ahead, if that's a right angle and it's a straight line, that's a right angle. So I pick one triangle and I write what they are. So it's a side, an angle, a side, and then I pick a direction. SAS. Well, that's one of my shortcuts. Right there. Okay, my next one, I only got 2 things congruent. I know this is going to be a right angle here. I need a 3rd thing to do one of my shortcuts because all I have is an angle and a side. It looks like they share this side completely. Okay, so now if I go ahead and label all of them, and now I'm going to pick a direction to go. Okay, so if I pick this way, SS, I have to go all the way around. I want to do it kind of in the correct order. So if I do ASS, that is not a shortcut, and you might see a video later on why that is not a shortcut. So anytime you have SSA or ASS or AAA, those are not shortcuts. Okay, my next one, I've got vertical angles in here. Okay, so if I label, I have an angle, and a side. So if I pick a direction, I got side, angle, angle. Well, that if I reverse it, that's angle, angle, side, which is one of my shortcuts. My next one here looks like they share a side completely. There are no vertical angles. I don't have any parallel lines to say alternate interior or corresponding angles. So I only have 2 pieces of information, which is not enough to say that those 2 triangles are congruent. So I'm going to say not enough info because I only have 2 of my 3 things to work. Okay, this one, I don't have vertical angles, I don't have parallel lines, they don't share anything. So 2 pieces of information is not enough to tell me that they're congruent. Okay, we can also make these things called proofs with these. So it's basically an argument establishing the truth of the statement that I give you. Okay, so I have this given statement. I need to prove that these 2 triangles are congruent. So I'm going to go ahead and label my two triangles in here to make it a little bit better. So I've got Q, P, L, N, and R. Okay, so first it says P is the midpoint of QL. So here's P, here's QL. Midpoint means middle, so that means the two sides of it are congruent. Then it says N and R are congruent. So N and R are congruent. Okay, I also have vertical angles in here, right here. They don't share a side, I don't have any parallel lines. Okay, so if I write in, I have an angle, and a side. So if I pick one of them and start to go a direction where they're connecting, I've got angle, angle, side as my shortcut. So yes, they're congruent by angle, angle, side, and I want to do it based on my angle, angle, side. Okay, so in this, I've got angle N is congruent to angle R. Then I had angle P, but I have multiple different P's. So if I emphasize Q, let me highlight, QPN, so angle QPN is congruent to LPR. Okay, and then I just need the sides that were congruent. So QP and PL. That was my angle, and my side. Okay, my next one, we got Q, R, S, T. Okay, QS and RT are perpendicular. Perpendicular makes right angles in there, so those angles are going to be congruent. And then RT bisects QTS. So QTS then, if it bisects it, that means those are congruent. And then they also share this side. So I've got an angle, a side, and an angle, which is going to give me angle, side, angle. So yes, they are congruent by angle, side, angle. So the angle, we could say QRT is congruent to angle SRT. Now we do our side, so RT, and since they share that RT, I'm going to say RT is congruent to RT. And then we got to do our last angle. So the one being bisected, so QTR is congruent to STR. That gets me my angle, my side, and my angle to prove my proof.